Hello viewers, in today's session we are going to discuss another important problem from three-dimensional geometry, and here we are going to discuss the concept of coplanar vectors, right? And we'll discuss the concept of coplanarity of three vectors in three dimensions using this problem, right? So here we have to prove that the vectors here three vectors are given, that is vector a minus 2b plus 3c, and minus 2a plus 3b minus 4c, and minus b plus 2c. So here we are given three vectors, and we have to prove that these three vectors are coplanar vectors. That is coplanar vectors are the vectors which lie on the same plane, and here a, b and c vectors are non-zero and non-coplanar vectors, right? So let us see how we can prove that these three vectors are coplanar vectors, that is vectors lying on the same plane, or these three vectors lie on the same plane using the concept of linear combination of vectors. So now let us denote these three vectors by a vector u, vector v, and a vector w, right? And here we have to show that these three vectors, vector u, vector v, and vector w, are coplanar vectors, that is vectors lying on the same plane, right? So in order to prove that these three vectors are coplanar vectors, we have to make use of the concept of linear combination of vectors, right? So three vectors are said to be coplanar vectors if any one of them can be represented as a linear combination of the other two vectors, right? For example, if we take the vector u, then u can be represented as a linear combination of vector v and vector w. So if we have two scalars l and m, then u can be expressed as l times vector v plus m times vector w, right? So if one of the vector can be represented as a linear combination of the other two vectors, then the three vectors are said to be coplanar vectors, right? And similarly, if we take vector v, then if v can be represented as a linear combination of vector u and vector w, then we can write here l times vector u, then we have m times vector w. And similarly, if w vector can be represented as a linear combination of vector u and vector v, then we can write l times vector v plus m times vector, here we can write vector u, and here we have vector v, right? So we can use any of these three representation, that is if vector u is represented as a linear combination of vector v and w, then the three vectors are said to be coplanar vectors. And if vector v is represented as a linear combination of vector u and vector w, then the three vectors are said to be coplanar vectors. And if the vector w can be represented as a linear combination of the vectors u and v, then also these three vectors are uh, said to be coplanar vectors. So here let us make use of this representation. So here u is given by this vector. So we can now write vector a minus 2 times vector b plus 3 times vector c. And here we have l times vector v, that is minus 2a plus 3b minus 4c, and here we have m times vector w, that is minus b plus 2c, right? And remember here L and M are two scalars, right? Okay, so now let us simplify it and let us collect the coefficients of vector A, vector B, and vector C in this expression. So we can now write minus 2L, and here we have vector A. So here we do not have vector A, right? So we have simply a minus 2L times vector A, and then we have here 3L, and here we have minus M, and here we have vector B, and then we have here a minus 4L, and here we have 2M and vector C. So here we have vector A minus 2B and 3C, right? So now if we look at this expression, then here the coefficient of vector A is 1, and here the coefficient of vector B is minus 2, and here the coefficient of this vector C is 3, and here the coefficient of vector A is minus 2L, and here the coefficient of vector B is 3L minus M, and here the coefficient of vector C is minus 4L plus 2M. So let us compare the coefficients of vector A, vector B, and vector C on both sides, right? And let us frame three linear equations in L and M, right? Okay, so now we can write here 1 is equal to minus 2L, equating the coefficients of vector A, and here equating the coefficients of vector B, we have 3L minus M, and here equating the coefficients of vector C, we have 3 is equal to minus 4L plus 2M. So now here we have three equations, right? So once we have three linear equations, we can select any two linear equations and solve them, right? And we find out the values of L and M, and then we'll see whether the values of L and M obtained by solving the two equations satisfy the third equation, right? So here we'll select the equation 1 and equation 2, and we'll solve these two equations to get the values of L and M. So now solving equation 1 and 2, from equation 1 we directly have L is equal to minus half. So let us take L is equal to minus half in equation 2. So we have 3 times minus half minus M is equal to minus 2. So we can now write here minus 3 by 2 minus M is equal to minus 2, and we have minus M is equal to minus 2 plus 3 over 2, that is minus 4 plus 3 over 2, that is minus half. So we have minus M is equal to minus half, so M is equal to half, right? So the value of L is minus half and M is 1 over 2. Now let us check whether these two values satisfy equation 3. If these values satisfy equation 3, then the three vectors are said to be coplanar vectors. So now substituting the values of L and M in this equation, we have now 4 times minus half, and here we have 2 times 1 over 2. So here minus times minus is positive. So we have simply here 2 times 2 is 4. So this is 2, and here 2 and 2 get cancelled, so we have 2 plus 1 is equal to 3, and here we have 3. So the values of L and M satisfy equation 3. So it implies that this vector u can be expressed as a linear combination of these two vectors, vector v and vector w, and this suggests that the three vectors are coplanar vectors. So now similarly, we can also use this expression, right? So vector v is expressed as a linear combination of vector u and vector w. So here the vector v is given by minus 2a plus 3b, and here we have minus 4c, and here we have L times vector u is a minus 2b plus 3c, and then we have m times vector w. So we have here uh, minus b plus 2c, right? So now let us follow the same steps. So here we have minus 2a plus 3b minus 4c, and here we can collect the coefficients of vector a, vector b, and vector c. So here we have simply L times vector a, and here we have minus 2L, here we have minus 2L, and here we have minus m, and here we have vector b, and then we have here 3L plus 2m and vector c. So again, comparing the coefficients of both sides, that is the coefficients of vector a on both sides, vector b on both sides, and vector c on both sides. So here we have L is equal to minus 2, and here we have minus 2L minus m is equal to 3, and here we have 3L plus 2m is equal to minus 4. So here the coefficients of vector A is minus 2, vector B is 3, and vector C is minus 4. So again, here we have three equations, and we can select any two equations to get the value of L and M, and then we try to satisfy the values of L and M in equation, the third equation, right? So here we'll select these two equations, that is equation 1 and equation 2. So from equation 1 we have directly L is equal to minus 2. So to get the value of M, we'll substitute the value of L in equation 2. We have minus 2 times minus 2 minus m is equal to 3. So this is 4 minus m is equal to 3. That is 3 minus 4. So we have minus m is equal to minus 1. That is m is equal to 1, right? So now let us see whether these values of L and M satisfy equation 3 or not. So here we have 3L plus 2M. So we have 3 times minus 2, then we have 2 times 1, that is equal to minus 6 plus 2, that is minus 4, and here we have a minus 4, right? So this implies that the values of L and M also satisfy equation 3, right? So it suggests that a vector v can be represented as a linear combination of the vectors u and w, and hence these three vectors are coplanar vectors. And similarly, we can take this expression, and we can follow the same steps, and we can prove that w can also be expressed as a linear combination of the vectors u and vector v, and the three vectors u, v, and w are coplanar vectors.